Question 43, Electrical Engineering, GATE 2017, Set 1. In the circuit shown below, the maximum power transferred to the resistor R is dash watt. For a detailed lecture on this concept, please refer the NPTEL video, Maximum Power Transfer Theorem by Dr. Nagendra Krishnapura, Department of Electrical Engineering, IIT Madras. Let's have a glance at Maximum Power Transfer Theorem before solving this problem. The maximum amount of power will be dissipated by a load resistance when that load resistance is equal to the Thevenin resistance of the network supplying power. And the value of maximum power is given by the Thevenin's voltage square divided by 4 times the Thevenin equivalent resistance of the network. Or this is also the load resistance, because only when the load resistance is equal to the Thevenin equivalent resistance, maximum power will be transferred to the load. Let's make use of this to solve this problem. We need to find out the Thevenin equivalent across the terminals of this load resistance. So we will replace this as an open circuit and find out the Thevenin equivalent resistance across the load terminals. VTH is the voltage across the load terminals. Let's find out VTH. VTH will be 5 volt minus the voltage across the 5 ohm resistor. Let us consider that the current of I1 is flowing into this loop. So VTH will be 5 minus 5I1 by Kirchhoff's voltage law. Let's find out the total current I1. In order to find out I1, let's replace this as a single branch by source transformation technique. If we replace, we will be getting 10 volt in series with 5 ohm resistor. Now let's apply Kirchhoff's law into this loop. By the Kirchhoff's voltage law, we will get 5 minus 5I1 plus 6 plus 10 minus 5I1 is equal to 0. So this implies that 21 is equal to 10I1. Therefore, I1 is equal to 2.1 ampere. Let's substitute the value of I1 and find out VTH. VTH is equal to 5 minus 5 into 2.1. This is equal to minus 5.5 volt. The Thevenin equivalent voltage is equal to minus 5.5 volt. Now let us find out the Thevenin equivalent resistance across the load's terminals. So for that we need to short circuit the voltage sources and open circuit the current source. So this path is shorted and this is shorted as well, and this is left as open circuit because we had a current source over here. Looking at the perspective of this resistor, the current will be passed into this. The current splits into 2 paths. One is the 5 ohm and one is this shorted path. Because of this shorted path, no current flows into this 3 ohm resistor. This current will flow into the 5 ohm and it will be back over here. We have to find out the resistance of this path. This resistance is the Thevenin equivalent resistance, which is 5 ohm in parallel with 5 ohm, which is equal to 2.5 ohm. Now we have found out the Thevenin equivalent voltage and also the Thevenin equivalent resistance. Therefore, the maximum power transferred is equal to VTH square divided by 4 times RL, which is equal to minus 5.5 square divided by 4 into 2.5. This is equal to 3.025 watt. So the answer is 3.025 watt. Thank you.